This is an AQA GCSE chemistry question. It's from the Trilogy 2019 paper and it's a higher tier question. And in this we're looking at rates of reaction and also considering exo and endothermic reactions. I'm going to recommend you pause as you go as we look at the question initially and then we can review later. So here is part A, part B, part C, and finally part D. 11 marks available in total. So for part A, a student investigated the rate of reaction between magnesium and hydrochloric acid and measured the volume of hydrogen gas produced. How could the student collect and measure the volume of gas produced? So this is about knowing key apparatus for chemistry practicals, and we would use potentially a gas syringe here. For part B, at the start of the investigation, the volume of gas was 0 cm cubed, took readings at 20-second intervals, and the readings are provided. Draw a results table. Include the student's results in the table. So in any table that you draw, you should have the independent and the dependent variable, or certainly the variables that are being compared. So I've put those in, and you'll also see that I've included the units. Time is in seconds, volume is in cm cubed. Because time is in seconds, I need to show that in seconds within the table, 0 all the way to 120. And I'm then putting the data in, but don't get mixed up. Remember, 24 is after 20 seconds. 0 must go in here, otherwise they're all wrong. So 0 all the way to 79 at 120. For part C, we've been provided with a graph. Determine the rate of reaction at 30 seconds. Show you're working on the graph and give your answer to two significant figures. The working on the graph is really important here. We're not asking for the mean rate of reaction. We want the actual rate of reaction at 30 seconds. For that, we need to draw a tangent to the curve that only touches the curve at 30 seconds. Once I've done that, I can work out the gradient of that line. So I'm using as much space as possible. I've got 20 going across and I'm going up to 90. And I've also got 0 to 50. Some good numbers to use. So that's 20 to 90, a difference of 70 centimetre cubed in 50 seconds. Now my rate is therefore going to be change in y over change in x. That's 70 over 50, giving me a value of 1.4 centimetre cubed per second. On to part D, the rate of reaction increases at higher temperatures. Explain why and answer in terms of particles. Temperature, you've got to remember some extra detail. In concentration, in pressure, in surface area, if you double the concentration, you double the number of particles in a given volume, you double the number of collisions, so you double the number of successful collisions, so you double the rate. But doubling temperature doesn't double the rate. It actually, every 10 degrees Celsius will double the rate. At high temperatures, particles have more energy. Now that means there are more frequent collisions. There will be more collisions per second. But that isn't the only impact. Because they are moving faster, they're hitting harder. So a greater proportion of those collisions will result in a reaction. And it's both of these separate points that contribute to the impact of increasing temperature on rate of reaction. And that takes us to the end of this question.